Ever wonder what's really going on inside the mind of an AI? I mean, how does it actually go from just seeing the world to making a decision? Well, today, we're going to climb the ladder of AI intelligence, step by step, to see exactly how these systems, or agents as they're called, actually think.
And let's ground this whole thing in a real-world example we can all wrap our heads around. A self-driving car. It's constantly taking in information, processing it, and then doing something. But what's the logic? What's its thought process? Let's break it down.
All right, so to figure this out, we're going to explore 4 basic types of AI agents. Think of each one as another rung on a ladder of complexity. And, we're going to start right at the very bottom.
First up, we have the simple reflex agent. Now, the key thing to get here is that it only acts on what its sensors see right now. It completely ignores anything that happened in the past. Think of it this way. It has zero memory. It's living entirely in the moment, just following a bunch of simple if-then rules.
It really is that simple. This is just pure stimulus response. It sees one thing, the brake lights on the car ahead, and it triggers one pre-programmed action. Hit the brakes. Super fast, super efficient, but, also incredibly basic.
So its whole universe, its entire thought process, boils down to that one simple question. It has no idea what happened a second ago, and it has absolutely no concept of what might happen a second from now. It is all about the here and now.
And that right there is the huge glaring flaw with this simple agent. I mean, what if a car was right in front of you, but it just switched lanes and is now blocked by a big truck? Our simple reflex agent, poof, it forgets that car ever existed. And that's a really big problem on the road, right?
So to fix that, we have to climb to the next rung on our ladder. We need an AI that can do more than just react to what's in front of it. It needs to be able to remember.
And this is where the model-based reflex agent comes in. And trust me, this is a huge leap forward. This agent actually keeps an internal model of the world, kind of like a mental sketchpad or a map. It's constantly updating this map based on what it sees, which gives it a form of memory.
Let's jump back in our car for a second. The model-based agent saw that other car change lanes. So even when it can't physically see it anymore, its internal model, its memory, is still tracking where that car probably is. It knows there's a hidden obstacle, and that is absolutely critical for making a safe move.
So you can see the difference, right? It's pretty stark. The simple agent is purely reactive. The model-based agent adds that crucial piece, memory, and that's what lets it handle what we call partially observable environments. Basically any situation where you can't see the whole picture at once.
Okay, so memory is a game changer, for sure. But reacting based on the past and present, well, it's still just reacting. What happens when an agent needs to actually think about the future to get something done?
And that brings us to section 3. This is where things get really interesting. We're moving away from agents that just react to the world and into agents that can actually make a plan to change the world.
Say hello to the goal-based agent. This is a massive step up. Instead of just reacting, this agent looks ahead. It can actually simulate different possible futures to figure out which sequence of actions will get it to a specific goal. It has an objective.
Imagine this. Your self-driving car is cruising along, and bam, road closed. A simple or even a model-based agent might just stop confused. But a goal-based agent, its goal is get to the destination. So it's going to start searching. It's going to find an alternate route. It's a problem solver.
This one question is basically the engine for everything a goal-based agent does. Every single action it considers is measured against that one simple test. Does this get me closer to my goal? It's this ability to plan, to think ahead, that makes it so much more flexible and, intelligent.
But just reaching the goal, is that the only thing that matters? Not always, right? There is one more rung on our ladder, and this one adds a really crucial layer of sophistication. This is the utility-based agent. It doesn't just ask, can I reach my goal? It asks, what is the best way to reach my goal? And to figure that out, it uses a concept called utility, which is basically a score for how happy or satisfied it would be with a certain outcome.
So here's the difference in a nutshell. A goal-based agent is happy with any route that gets you to your destination. But a utility-based agent, it weighs the trade-offs. It's looking for the optimal solution, not just one that works.
Think about your GPS. A goal-based agent might just pick the fastest route, even if it's full of potholes and stop-and-go traffic.
A utility-based agent, though, it considers other things. It might balance speed against safety, ride comfort, even fuel efficiency to find the route that maximizes your overall satisfaction, your utility.
Okay, we've climbed this whole ladder, from basic reflexes all the way up to complex optimization. But there's a missing piece here. How do these agents get better? How do they learn from experience? Well, that's where one final, super important component comes in: the learning engine.
Think of this as a 4-step loop that lets any of these agents improve. First, you have the performance element. That's the part that's actually out there driving the car. Second, the critic looks at what happened and gives feedback. Hey, that was a good move or that was a bad move. Third, the learning element takes that feedback and actually tweaks the agent's rules to do better next time. And finally, the problem generator suggests new, maybe unusual actions to try out, so the agent can discover even better ways of doing things.
Okay, let's bring it all home. We're going to put our 4 agents through a final driving test to really summarize everything we've talked about and see how they all stack up against each other.
So this chart really lays it all out for us. We started with the simple reflex agent, which is just pure reaction based on if-then rules. Then we added memory, and we got the model-based agent, which can handle things it can't currently see. After that, we added planning, which gave us the goal-based agent, which can figure out how to get to a destination. And finally, at the top, we have the utility-based agent, which doesn't just find a path, it finds the best path. You can see how each step builds on the last one, creating a smarter, more capable system.
And that brings us full circle, right back to our original question. As we climb this ladder of intelligence, from a simple reflex all the way to an AI that's trying to optimize for our safety and comfort, you've got to ask yourself, which one of these would you trust to take the wheel?